The table shows the total cost of apples at store A. The graph shows the total cost of apples at store B. Do the table and the graph represent the same ratio relationship? Explain how you know. So what I'm doing is I'm going to find these values over here to see if I can match it up. So first I have a 3. I don't have anything at 3. Over here I actually have, and I'm just going to write on the side what they are. So we have 2 and 3, all right? Then I have 4 and 6. Then I have 6 and 9. And then up here I have 8 and 12 for my points. So now that I've determined, and the way that I found those is just starting at the origin, and I moved to where I found the points on the line, and the first number I saw here goes for my x coordinate, and then I look to the left where the point is, and that's my y coordinate. So that's how I find those values. So what we're trying to determine is if these are equivalent. So I look for 2, 4, 6, 8, any of those numbers to be represented. Here, right here, I have 6 and 10. So the number of pounds of apples is 6, and its total cost at store A is $10. So over here I have 6 pounds of apples at store B, and the cost is $9. So they're asking, are they the same ratio relationship? The answer is no. And it's simply because for 6 pounds of apples, it costs different prices at the different stores. So that's it. That explains the exit ticket from today's lesson. All right, so this question says, Scott and Una are mixing fabric dyes. They each create their favorite shade of red dye by mixing scarlet red dye and cherry red dye. Do Scott and Una create the same shade of red dye? If yes, what is the ratio of the number of ounces of scarlet red dye to the number of ounces of cherry red dye they both use? If not, what are the ratios that each person uses? So here in this first double number line, we see Scott's red dyes, and in this second one, we see Una's red dye. So again, we're comparing the number of ounces of scarlet red dye to the number of ounces of cherry red dye in each of these. So what I'm doing is just like I did on the last problem. I'm going to find a X value that I find in both of them, and that is how I'm going to compare if they have a ratio relationship, if they're equivalent, or in this case, if they create the same shade of red dye. So starting here, I go from 0. I'm increasing by 5s. Here, I'm increasing by 20. So I know that 20 is the first common number that they both have. So I'm going to go ahead and get my annotation tool up, and I'm going to circle 20 and 8. So this 20 represents scarlet red dye ounces, and this 8 represents cherry red dye ounces. So then I'm coming down to Una's, and I have 20 and 9. So that means Scott's red dye has a ratio of 20 to 8, and Una's has a ratio of 20 to 9. So that tells me that these do not have the same shade, because when Scott uses 20 ounces of scarlet red dye, he only uses 8 ounces of cherry red dye. And when Una uses 20 ounces of scarlet red dye, she uses 9 ounces of cherry red dye. So this tells me that these two are not equivalent, and in this case, they do not have the same shade. All right, so the 6th grade art class makes candles. Students use 3 tablespoons of vanilla oil for every 2 pounds of wax to make the candles. Which representation correctly showed the relationship between the number of tablespoons of vanilla oil and the number of pounds of wax? So first things first, we want to make sure we identify the key components of this problem. So it's important to know that for every 3 tablespoons of vanilla oil, they have 2 pounds of wax, and that makes the candles, okay? So I know that I'm comparing vanilla oil to number of pounds of wax. So we know that it's a 3-to-2 ratio. So that means, looking at part A, we see that the vanilla oil is up top and the pounds of wax, so that does match what I'm comparing. So when I have 3 tablespoons of vanilla oil, that's 2 pounds of wax. So that matches. So when you're looking for equivalent ratios, you try to find your base ratio. And since I know 3 and 2 are a base ratio, because those two numbers can only both be divided by 1, then that tells me each time I'm going to increase by 3 at the top, and down here I'm going to increase by 2. So I look, so 3 to 2, then we have 6 to 4, 9 to 6, 12 to 8, 15 to 10, and 18 to 12. Another way to tell is from here to here, I multiply it by 2. So then I have to multiply by 2 here. Here I multiply by 3, I multiply by 3 down here. 3 times 4 is 12, 2 times 4 is 8, 3 times 5 is 15, 2 times 5 is 10, and 3 times 6 is 18, 2 times 6 is 12. So that tells me that this is one of the options that I will be choosing because it does match. So then I'm going to look at part B. So part B looks a little different. We have a tape diagram. So in the tape diagram, we see 3 boxes representing vanilla oil, and we see 2 boxes representing wax. Well, guess what? Our ratio is 3 to 2. So it doesn't matter what value is inside the box. When the ratio is 3 to 2, as long as every single value is the same in each of the boxes, then guess what? That represents an equivalent ratio, and we can compare it. I know that 5 times 3, or 5 plus 5 plus 5 equals 15, and 5 plus 5, or 5 times 2 equals 10. So then guess what? I'm going to go over here to this one, and for every 15 tablespoons of vanilla oil, I should have 10 pounds of wax. So I know that this is also a correct statement. Part C. So here, number of tablespoons of vanilla oil, and here is the number of pounds of wax. So I started my origin, and I'm in between 2 and 4, so I know that represents a 3, and it's a 3 to 2 ratio. So for right now, we're absolutely on track. So then I'm going to go back. I go to 6. It represents a 6 to 4 ratio. Guess what? I already know from the double number line that that is a true statement. So now I'm going to go to 9. And when I go to 9, I look over and it says 6. So let's verify. We have 9 to 6. So that represents a true statement. So the number of tablespoons of vanilla oil do match the number of pounds of wax that we found in our initial one. So C is also a true statement. We have 3 to 2, we have 6 to 4, and we have 9 to 6. So then part D, I'll go ahead and stand up for this one. We have a 3 to 2 ratio to start, okay? And then we have a 4 to 3 ratio. And then we have a 5 to 4 ratio. So what we see is happening here, they're adding 1 each time. So then if we were to continue, the next value would be 6 here and 5. So I already know based on these that it's not correct, but if you just needed to see it, then check this out. We have 6 and 4. So this tells me that this one is not a representation of 3 tablespoons of vanilla oil for every 2 pounds of wax. So I'm gonna have to clear the screen so that I can go ahead and move on to the next parts. So for right now though, we determined that A, B, and C are true statements and D is not a true statement. So then E, we remember that our initial base ratio, and I'm just gonna write that, for the number of tablespoons of vanilla oil was 3, and the number of pounds of wax was 2, okay? So as we progress, we can check with this one. So to get from 3 to 6, I multiply it by 2. 2 times 2 is 4. To get from 3 to 12, I multiply it by 4. 2 times 4 is 8. To get from 3 to 18, I multiply it by 6. 2 times 6 is 12. So that makes this also another true statement. So far, the only one that we've proven to not represent the 3 to 2 ratio is part D. So our last one, part F. So we see it says number of tablespoons of vanilla oil and number of pounds of wax. So I go here, and the first number I get to is a 2 for 1. Okay, so these are smaller than any values that we've seen. And then I go and I have a 3 to 2. So I started with a 2 to 1. Okay, and then 3 to 2, which I remember that 3 to 2 was our base ratio here. So when I see that, I would naturally be like, oh, this means these are right. But then I go 4 to 3. So I know that that is not correct and that this is not correct. We were able to prove that these were not accurate in the prior one. So going forth, we know that the simplest form of 3 to 2 is 3 to 2. So if they give you anything that's less than, that automatically lets you know that this is not a true statement, okay? So in this particular problem, and I'm just gonna clear the screen and make it a little bit smaller. In this particular problem, we were able to determine that A, B, C, and E are all representations of 3 tablespoons of vanilla oil for every 2 pounds of wax. Adesha's recipe for tea calls for 4 tablespoons of milk in 3 cups of tea. Kelly's recipe for tea calls for 7 tablespoons of milk in 5 cups of tea. So they want us to show the ratio relationship between the number of tablespoons of milk and the number of cups of tea in Adesha's recipe, and create a graph, a double number line, or a table. So first I'm going to highlight the stuff that's for Adesh. So I know that Adesh chose 4 tablespoons of milk for every 3 cups of tea. So I'm going to label. We have tablespoons of milk, okay, and then cups of tea. So I know that it's a double number line that I'm going to use first. I probably shouldn't make these lines too long so that I have space. So I know with any of them, we're going to start at 0, 0. And then I know for every 4 tablespoons of milk, there are 3 cups of tea. So this is my simplified ratio. As I mentioned in one of the last problems, that means that I can only divide those numbers both by 1. So yeah, I can divide 4 by 2, but I can't divide 3 by 2. So that means they can only both be divided by the same number of 1. So this tells me what I'm going to increase by each time. So I know that from here, I'll have 8 to 6, 12 to 9, 16 to 12, and then 20 to 15. So I created my double number line to represent Adesha's. So now I'm going to take a look at Kelly's recipe. So Kelly's is 7 tablespoons of milk for 5 cups of tea. So I'm going to go ahead and I'm going to do a table for hers. So we'll put milk here and tea over here. So for here, we start with 7 to 5. So then I can go to 14 to 10 and 21 to 15. And I'm just going to stop right there because I know that I have these numbers in common, and that's what we're trying to do. We're trying to determine in the end if they are equivalent. So as you can see here, I've created that. Part C says, do Adesha's recipe and Kelly's recipe use the same ratio relationship between the number of tablespoons of milk and the number of cups of tea? So I'm not going to actually write my response on here, but I will say it out loud. So I'm trying to see, I look up here and I don't see any of these numbers represented here. So then I'm going to go down here. And so that's when I knew I saw the 15. So I'm actually going to circle this one up here. And then I'm going to find 15 here and I'm going to circle here. So what does this tell me now that I see? That tells me that for every 20 tablespoons of milk, Adesh requires 15 cups of tea. Okay, so for every 20 tablespoons of milk, that's 15 cups of tea for a dish. And when I look down here to represent Kelly's, for every 21 tablespoons of milk, that provides 15 cups of tea. So although they both provide the same amount of cups of tea at a certain time, they have different tablespoons for milk. So that tells us that the ratio relationship is not the same. They have a different ratio relationship. 8,448 divided by 2. So first we determine how many times can 2 go into 8. I know that it can go in there 4 times. 4 times 2 is 8. So I'm going to do that and I'm going to subtract. And I'm left with 0. I bring down my 4. And I know that 2 can go into 4 2 times. 2 times 2 is 4. So I'm left with 0. I'm going to bring down my 4. Again, I know that 2 can go into 4 2 times. 2 times 2 is 4. I have 0 left. Now I'm going to bring down my 8. I know that 2 can go into 8 4 times. 4 times 2 is 8. So I always like to make sure that when it's possible, when I don't have any remainders, that I zero that out. So I know that I did my correct. So to answer, and that was problem 6, 8,448 divided by 2. This is how you come up with the answer. So I'll also do on this page, so I will also do 1,272 divided by 3. So I determined how many times can 3 go into 12. 4 times. 4 times 3 is 12. So I'm left with 0. I'm going to bring down my 7. I know that 3 can go into 7 twice. 2 times 3 is 6. So I have 1 left over, and then I bring down my 12, or my 2, and I have 12. And 3 can go into 12. 4 times 3 is 12. And so I'm zeroed out. So that is how we solve problem number 7, 1,272 divided by 3. So number 8 says the tables show the ratio relationship between the number of ounces of raisins and the number of ounces of nuts in a trail mix recipe. So I'm looking to complete the table. I noticed that the number of ounces of raisin is 3 for every 2 ounces of nuts. So from 3 to 6, I know that I multiplied 3 by 2. Here, I multiplied it by 3. So I can complete these first few. So 2, I want to multiply that by 2 here, and then by 3 here. 2 times 2 is 4, and 2 times 3 is 6. So now that I've completed those, I can go ahead and start working towards the other ones. So to get from 3 to 1, obviously that's a smaller number, so that represents that I divided. And 3 divided by 3 divided by 3 gives me 1, or any number divided by itself will give us 1. So guess what that means? I also have to divide 2 by 3. And what does that look like? It looks like a fraction. 2 over 3. Okay? And so then over here, we have one more blank. So I need to figure out, how did I get from 2 to 1? Again, this is a smaller number, so it represents that I divided it by 2. And so to get to the 1, so I have to do the same thing over here. I have to divide the 3 by 2. And what does that look like? 3 halves, or 3 over 2. Okay, so that's how we do that. So how many ounces of raisins are needed for every 1 ounce of nuts? So ounces of nuts, 1. So I need 3 halves ounces of raisins, okay? 3 half ounces of raisins. And then how many ounces of nuts are needed for every 1 ounce of raisins? So I go over here to 1 ounce of raisins, and I see that I need 2/3 ounces of nuts for every 1 ounce of raisins. And that completes number 8. We have one more problem, number 9, which states, which pair of statements accurately describe the ratio relationship shown in the table? So here we see a 3-to-1 ratio. Anytime you have 1 as one of your numbers in the ratio, that automatically tells you that it's in its simplest form. Remember, to be in its simplest form, or the base ratio, or lowest terms, means that you can only divide those numbers by 1. So if one of the numbers in the ratio is 1, obviously 1 times 1 gives us 1. That's the only way we can get 1 when we're multiplying. So that means it's already in that base ratio. So let's look at the statements. So we have the ratio of the number of cups of flour, so this represents cups of flour, to the number of cups of water is 1 to 2. So this is saying that there are less cups of flour and twice as many cups of water. I determined that to be false based on what I see, because I see that there are more cups of flour than there are cups of water. So I can determine that this is not a true statement here. So look at B. The ratio of the number of cups of flour to the number of cups of water is 1 to 3. So I look at flour, and because that's mentioned first, the number that correlates to it should also be first in my ratio. And I see that 3 is the representing number and 1 represents water. However, they have them switched. Okay, so that tells us that these are not a clear representation that accurately reflects the table shown. So what they did was switch them around. All right, and with ratios, order matters. So we need to make sure that we are not switching anything around. C, the ratio of the number of cups of flour to the number of cups of water is 3 to 1. That actually matches. Number of cups of flour is 3, number of cups of water, 1. So I know this to be a true statement, and here for every 3 cups of flour, there's 1 cup of water. So each of those had that second statement. That's just another way to describe the ratio relationship. So they give you 2 different ways to read it. And then D, the ratio of the number of cups of flour to the number of cups of water is 3 to 6. So I look, cups of flour, cups of water. They're still trying to put water as more than flour, and we know that that is not correct. So this tells me that we are done.